All right, welcome everybody. Let's do this. So today we'll be at lesson 31, solving systems of equations graphically. So this is day one of a two-part series. So let's look at the first part. Here, make sure you have your calculator and it says to reset it. So how do you reset the calculator? If you forgot, remember it goes second plus 712. Bam. And the calculator's reset. Okay, so what do we want to do first? Let's graph these two lines. So the first graph is negative x plus 6, and the second one is 3x plus 2. So let's just go into our calculator and do it. So here we go to y equals, and then on the top, let's put in negative x plus 6. And for the next graph, let's put in 3x plus 2. Okay, and we hit graph. And why do I have an error? Oh my god, rookie mistake. I put a minus sign. It should be a negative sign. So that should be a negative x plus 6. And let's hit graph. Okay. So notice that the graph should look like this. And here, notice that this negative x plus 6 will be the blue line. So notice that it kind of goes right here. It hits at 6 over here. And then we can just kind of draw a line like this. And then here, for your other graph of 3x plus 2, it hits at the y-axis at 2, and it hits over here at this point. And notice this is the intersection, okay? Okay. Now what I want you to do is take your calculator and try and zoom in, but where is this intersection point exactly? Where should it be, okay? So here, if you zoom in a little bit, it's a little blurry on my screen, but the idea is that this intersection point should be 1, 5. Okay, that's the intersection point. So try and find that on your calculator. Like if you go to your right 1 and up 5, and then bam, that's the intersection right here. Okay, so let's take a look at the next part. What is it saying? It's saying what does the solution, or graphically, what does the solution for these two lines represent? So the intersection point represents the solution for the equation. So we could have that here. Okay, where these two, like this graph over here is negative x plus 6 and this graph is 3x plus 2, where they intersect at 1, 5, that will be our solution. So we know at 1, 5, here our x is 1 and our y is 5. Okay, so let's take a look at the next part. Here it's saying, let's imagine, how would you prove that it intersects at 1, 5 over here? Okay, how can we prove that? And this is the question. It says, visually, we see that x is 1 and y is 5. How can we justify this without a graph? Okay, so the idea is, how do you know x is 1 and y is 5 with no picture? Okay, how would you be able to solve this equation? The idea is you want to take negative x plus 6, right? That's one of the graphs. And take these two, and the other one is 3x plus 2. Let's make them equal to each other. Okay? This will help us find the solution for 1, 5. So how do you get x by itself? Okay? Pause the video and try and solve it by yourself, right? How do you get x by itself? Well, what's the first move? Plus x. And now we have, this becomes 0, right? So you have 6 equals 4x plus 2. Then what do? Minus 2, and now we have 4 is equal to 4x, right? So if 4 equals 4x, divide both sides by 4, divide both sides by 4 to get rid of this over here, and now you have x equals 1, right? But we already have that, right? But we got this from looking at the visual. To algebraically show it, we have to make it equal to both sides, right? So now you know that x is 1. How do you get y? Just plug in x equals 1 into either one of the equations. Notice that if negative x plus 6, so if y is equal to this, right? Y is equal to negative x plus 6. Well, x is 1, so y is equal to negative 1 plus 6. Y equals 5. Okay? So this is how we could show it algebraically by making the two equations equal to each other. All right, so we noticed how we had two lines and they intersected each other. Let's look at the next one. Same idea. What I want you to do is graph these two equations and see what happens, right? So let's see. The first one, negative x plus 6, is still the same. Let's look at the next one. It's just clear it, negative x plus 2. So let's take a look here for this graph. Notice that the blue line still stays the same at negative x plus 6. But here, it looks like the graphs are not intersecting each other. So you have one graph that looks like this, and you have another graph that looks like this, okay? So let's see what's happening here. It says graphically, is there a solution for these equations? Nope, there is not, because they do not intersect. Okay, so visually, if there is a graph and they don't intersect, there is no solution. Okay, but this is a really nice question here. So let's just take a look at this. Here it says, we see there is no intersection, thus a solution does not exist. But what if we didn't know the graphs didn't intersect? So let's say if you took these, let's say you didn't know what these two graphs look like, okay? And let's see the next part. What would happen if you tried to find the solution? So like you saw how before, how did we find this solution over here? What did we do? We just took the two equations and made them equal to each other. So let's see what happens here. There is no solution. But let's say if we tried to find the solution, what would it look like? So let's take a look. If I have negative x plus 6 equals negative x plus 2, okay, well, let's see. What happens if we just do plus x plus x? Let's say if I add x on both sides. Well, then what do we get? This is 0. This is 0. So you have 6 equals 2. Okay? Like, that is very weird. This is not true. And when you have something that's not true here, you know there can't be a solution. Okay? So this is false. Okay? So before we saw here, when we tried to find the solution, we were able to get x by itself. Here, when there is no solution, we got something that didn't make sense. Okay? Let's take a look at the last possible combination. Here, we have two lines. Let's take a look. They are negative x plus 6 and negative x plus 6. Well, these are just the same lines. So you just have one line, that's y sub 1, is the same as the other line. So let's take a look here. Here, are there solutions, or what are the solutions for the systems of equation? Like, what are the solutions here? You know, pause the video, think about it. Like, what are the solutions for this equation if you have one line on top of another line? Notice that here you say there are an infinite amount of solutions. Okay? And why is this the case? Because if you have one of the graphs and it looks like negative x plus 6 is equal to negative x plus 6, right? Imagine if you say x equals 1. Well, if x equals 1, then you have negative 1 plus 6, you have 5 equals 5. So it makes it true. What if I say x equals 2? If I say x equals 2, then negative 2 plus 6 is 4 equals 4, and that also works. X can be any number you want. You could say x is 1.1, x could be 1.2345, it doesn't matter. Because they intersect at an infinite amount of possibilities. And let's see, what would it look like if I tried to solve it, right? Like, let's say if I tried to solve the equation. Well, negative x plus 6 equals negative x plus 6. Let's say if I try and get x by itself, right? So negative 6, negative 6. So negative x equals negative x. And then let's say if I multiply both sides by negative 1, then you just have x equals x. So, like, if I say x equals 2, 2 equals 2. So that's what it would look like over here. Okie dokie. So very nice. Let's try and take a look at this next part over here. A, B, and C are extremely, extremely important. Okay, so let's take a look over here. Here, let's read this together. And I'm sorry about this line over here. The print wasn't very good. But here, we have seen that a pair of lines, right? So let's focus here. It says we have seen that the pair of lines can intersect in 1, 0, or an infinite number of points. So let's say if you have two lines, right? We have, wait, my bad. Okay, so if you have one line, like if I have two straight lines, notice that they can intersect at one point, or they could have no intersection points, right? That was one possibility. Or they were the same line. So notice here, how many solutions do we have here? This is just one solution. Here we have 0 solutions. Here we have infinite amount of solutions. And the question we have over here is, are there any other possibilities? Okay, I want you to think about it. Pause the video. Imagine if you had two straight lines. Can there be another way we create a solution? Or are these three the only way? Okay, so if you want to see it, these three are the only way. There is no other way you could take two straight lines and have them interact in different ways. They're either going to intersect at one point, be parallel, or be the same line. Okay? What I want you to do is read part B. Let's see what part B says. It says, suppose that instead of an equation for a pair of lines, you were given the equation for a circle and you have a line. Imagine if you have a circle and a line. How can these two figures possibly interact with one another? Okay? So imagine if you have a circle and a line. What I want you to do is, what are all possible ways a circle and a line can interact? Okay? So notice that if you want to see how it's done, here, one way is they don't intersect. They don't intersect, right? Okay, a second way they could have is, imagine if you have a circle, and then if you have a line, you could hit 2 points over here, so they could intersect at 2 points. Okay, and what's the other way? The third way is if you have a circle. Well, let me be consistent with colors. If you have a circle, what else could happen here? It could touch at just 1 point. So here it's one intersection. And when this happens, we say that this line is tangent to the circle. Okay? So that was part B. So no, let's just try and see the visuals, right? We talked about two lines. We talked about a circle and a line. Let's take a look at part C, the last part. It says, given the graph of a parabola. So what does a parabola look like? Remember, a parabola looks like this. Okay, this is some x squared. It says, what are the possible ways that a line can intersect with a parabola? Okay, so what I want you to do is, what kind of different interactions could a parabola and a line have, right? So let's take a look. You could have a parabola like this and a line like this. So no intersection point. You could have a parabola like this, and you could have, one. Oh, actually here we could say this has 2 intersection points, right? So it could intersect 2 intersection points. This is 0 intersections. And what else could happen? You could have a line, and what I tried to draw before is you could have a line that is tangent. Notice how here this line hits the parabola at just 1 point. Okay, so this is one intersection point. Okay, that's it for this video. I hope you enjoyed it. The idea for this is just a general idea of how these graphs could look like. Okay, we'll see you the next part.